Hey, thanks for coming back. Today we're going to look at making a D-guard trench knife. We actually can't make a normal trench knife in Canada. Those are actually prohibited. This one is for an active member of the Canadian Armed Forces and includes some laser etching of his unit and insignia. And as always, if you like these, please hit that like button and subscribe. We're going to make this out of a bar of 5160, so let's throw it in the forge. I'm going to use my 16-ton coal iron press to actually get this down to a 1-inch width by a 1/4 inch thick. Then we'll actually hammer in the tip. A quick check against the profile I drew out on the anvil, and everything looks good. Flatten it out using the kiss blocks to make sure that we've got a uniform thickness and we're ready to hammer in the tip. What you can't see here is there's actually a newspaper reporter off to the right hand side who desperately wanted to come out and see a bladesmith hammering. With the profile done, I'm making a couple marks where the tang is going to start, and then I'm going to press in the tang. I made this surface grinder for when I do swords. It's a little bit big for this task, but it works. We end up with a nice flat blade. And now, time to mark it up so that we know where our grind lines are for essentially a dagger. I start off, especially on daggers, by making a center line that we measure everything against. Because this is a symmetrical blade, everything's got to come off that center line. We'll take it over the 2x72 with a really coarse belt, 36 grit, and grind out the profile. Once we've got the profile done, then we're going to start on the bevels. On a symmetrical knife, one of the ways that I check the symmetry is to look at the curve on one side of the template, flip it over, and it should fit the other side of the template as well. With the profile completely done, next up we have to set the grind lines for that nice gradual taper into the ricasso. To do that, I'm actually going to use some drafting tools. I've got this old set of French curves, some of them broken, and I'm actually going to find a nice gentle curve that matches and then repeat that on the same side, ensuring that I get exactly the same curve on both sides of the bevel. At this point, the blade thickness is 7/32, so I use a 7/32 drill bit to mark a grind line along the edge of the blade. To keep the weight down on this blade, I'm going to do a hollow grind, so I'm going to use my 8-inch wheel and get it close to my grind lines. In order to get that nice taper near the ricasso, I can't hold the blade straight and steady. I actually have to rotate it as it comes close to the ricasso. So here I am starting near the ricasso. The blade is angled more, and then as I get down to the main part of the blade, I'm going to pull it straighter, and that'll give me that nice curved ricasso area. And at this point, it's really starting to look like a trench knife. To square up the shoulders of the ricasso, I'm going to use this file guide. And now we're ready for heat treat. But, wouldn't you know it, I blew an element. So now I had to fix that before we can go on. With the element fixed, we can move on to quenching. The blade's been normalized and we're ready to throw it in the quench, give it a good shake, look straight, throw it in the straightening jig. Came out pretty close to HRC 60. My files only go in increments of 5, and 55 skated really fast. 60 kind of bit. I was tempted to go to 65, but I'm sure it's like 58, 59. We'll take it over to the grinder now and do some finish grinding, taking off all that no scale that I painted on before we heat treated. So once we've got it down really close to our final shape, we have to hand sand it. But it's a concave grind, which means I need to somehow get a curve grind. So I'm going to actually make myself a block. I'm going to just take a block of wood, trace the curve of my wheel, cut it out, and now I've got the same curve I was grinding at that I can actually glue some sandpaper to. After hand sanding, I decided to square up the shoulders a little bit more. I didn't really like the finish of them from when I used the file guide, so I used the mill now to actually square them up true. Time to move on to the part I was terrified of. This is a complex build. There's a guard, a D-guard, and a pommel. It'll have to be assembled as a frame. So here I'm actually using the mill to cut my slot. I still have to file it to make it fit perfectly, but eventually my milling is getting closer. When you need a tool, you make a tool. For doing guard slots, I actually took a file and I ground it smaller and removed the file from the edge of the file so that I don't inadvertently make it bigger. Here I'm really concentrating on going back and forth in a nice level pattern, using the vise almost as a guide block. We'll do a quick cleanup, and then we're going to mark it up with some marking fluid and add a little bit of contour to the guard itself using some of my old drafting tools again. You can see by my paper towel, I do a lot of math. I use some of the artist rules like rules of thirds, the golden triangle, all of that for setting up the various proportions of my guards. I'm going to do a test fit, and you'll see it really doesn't fit close yet. That's because I haven't rounded over the corners in the guard to match the curve where the tang meets the ricasso. So what I've done is I've actually scribed where the blade meets the guard, and now I'm going to use my Dremel and a diamond bit to actually round over those corners and create a nice square edge. And after making those two curves match the curves on the tang, we get a nice tight fit up. And now it's time to finally shape the rest of the guard. Now that it's all up to shape, time to try test fitting it. Now, here was my problem. I made this such a tight fit, I had a real bugger of a time getting it off. So here I am just trying to tap the guard back off. It did loosen up from repeated fittings eventually, but this is a nicely tight fit guard. For the D-guard portion, I'm using a little bit of 1/4 inch by 3/8 inch stock. I did try forging one out, but I couldn't get nice angles that I wanted. So I'm actually going to cut out some pieces and use the TIG welder. Flip it over and do the other side. Now's the part where I become a real welder. I take it over to the grinder and grind off my horrible welds. The only criteria I needed was for them to be solid at this point, so they didn't have to be pretty. During the welding process, I did pick up a little bit of a warp. So that's what a 16-ton press is good for. Heat it up a little bit with a torch, put in some flattening blocks, and voila, a straight guard. With the D-guard made, we now need to create the frame. So what I'm going to do is mark up a piece of steel, trace the tang on it, and cut out a hole for the tang to slide into. Using the Bladesmith's multi-tool, we start cutting out the slot for the tang and finish up the cross using the mill. Didn't need to do it this way, it's just I've got it and it's convenient. And this is what happens when you go too fast. You break your bit. Luckily, I was 88% of the way through, so a little bit of force bending it over and the piece snaps off. I'm not worried because it's not really a strength or structural piece. I'm going to clean up the bottom where I broke this off. I use this cool little pipe grinder. It was just a cheap little addition from the local hardware store. And then I used the Bladesmith's multi-tool to knock off a bunch of the excess material before I finally shape up the frame. Now that the frame is shaped, we actually have to add a couple small pieces to the back of it so that we can actually drill the pommel nut hole through. Right now, it would really make that frame weak. By adding a couple pieces to both sides of the frame, we actually get a solid pommel. I'm going to use the same curve using my 8-inch wheel, but I need to make sure that the grind on my curve is perpendicular. So I use a couple 3-2-1 blocks, probably one of the more useful things that we can have. And I'm going to clamp them on my table to make sure that I'm actually getting a perpendicular grind. And once I've got the pommel pieces done, I'm going to use the TIG welder now to weld them onto the actual frame. I think one of the nicest things I've added to the shop is the TIG welder. I don't think I use my MIG or stick anymore since I got the TIG. And then back to the grinder to turn me into a real welder. And with the pommel pieces added, we now actually have enough mass to drill a hole for our pommel nut to go into. I go back to the mill, I drill a pilot hole, and then I actually drill the real hole. With the hole in the pommel, now we need to put some alignment pins into the front of the frame so that we can match it up with pins in the guard. I wasn't thinking. This just moved around way too much. So my solution was to actually use a piece of steel, clamp it into the vise, and then clamp the frame against the steel. That kept it solid enough to drill. I ended up really screwing up because that actually broke the bit off in the hole. And here I'm actually using a carbide mill, a downcut end mill, to actually mill out the drill bit. I ended up having to put in bigger pins than I originally planned, but I did finally get that drill bit out. Mark the pinholes in the guard and then go drill the holes so the pins will seat in the guard and the frame. All the pieces are now cut, and it's time to actually add some 1032 rod to the back of the tang so that we can actually screw on the pommel nut. I've done both methods where I weld in some 1032 or I actually shape it and thread it. I find the hardened steel really hard to thread, and it's really hard on my dies. So I kind of prefer this method where I cut a slot, use the TIG welder to weld in some 1032 to screw on the pommel nut with. I actually welded it up with everything in place, the frame and the 1032. That was to ensure proper alignment with the hole that was going through the pommel. And as always, finish my welds up on the grinder, do a quick test fit, and we're almost ready to weld on the D-guard. First, we have to grind in the gears on the bottom of the D-guard. I did way more napkin math than I needed to, but eventually I got where I needed to go. Again, welding on the D-guard took a little bit of creative clamping, so I used a scrap piece and a bunch of ice grips to make sure I had everything lined up where I needed it to be. And as always, none of my welds are finished until I get to the grinder. For the scales, we're going to use some of this black and olive micarta. Should look really nice on a military knife. There was a lot of back and forth that I've cut out at the grinder just to make sure I got an exact fit. It's actually pretty snug and tight, which is really nice. Next up is to drill the holes through the micarta, and we'll start off by drilling holes in the frame that will match up. For the mosaic pin, I didn't want to put a big hole all the way through the tang. So what I did is I drilled a small hole, used a micarta pin, and then simply drilled a small indent into each piece of the mosaic pin. That way there's a positive connection between all of the pieces, but I haven't drilled this huge hole through the tang. Because we're going to parkerize everything, what I really needed to do is make sure that this actually assembled and came apart like a takedown knife. I'm going to glue it together, but I needed all of the pieces to fit together in a finished state. With the blade done, we're going to go back to the mill and turn a pommel nut. First step is to drill a hole through the throat. Face everything off so we know we're square, and then drill a hole for the threaded rod. One really big advantage of the mill is that I can use the centering stock and make sure that my threads are perfectly aligned in the hole as I thread it. A quick check, and then we'll turn it down so that we can countersink it into the pommel. Part it off, and then we'll flip it around so that we can actually shape the end of the pommel nut. I did the end of the pommel nut in 20,000 inch steps, but I also sharpened the point so that if you were to strike tempered glass or auto glass, it'll actually shatter the window with that sharp point. With the pommel nut done, I drill the correct size of countersink into the pommel itself so that we get a flush mounting pommel nut. A quick test fit of the knife, it comes together exactly like a takedown should, but we are going to glue it together. Once we've got all of this done, we're then going to go over to the laser engraver. I'm going to do a separate video on laser engraving. It's a process that deserves its own video sessions, so stay tuned for that one. I'll put a link in the description. This is a pretty cool process. It's actually creating a 3D relief of the beaver skull with a beret, but it does take about 4 to 5 hours. So I've skipped a bunch, put in a couple cuts, but at the end we end up with a pretty cool looking insignia on the blade. Add my touch mark and the other insignias, and now we've got our finished blade ready for parkerizing. To parkerize it, I'm going to use this kit I picked up from Maritime Knife Supply. I'll throw a link in the description. Basically, it's a two-part process. You soak it to add the parkerizing solution. It'll turn the blade black. But then I had a little bit of a disaster. There is a pan on the barbecue that I've got heated up to about 180 degrees. Unfortunately, it's a little bit of a breezy day, and you'll see that we have a little bit of a disaster as the tripod gets knocked over into the barbecue, and that pretty much put an end to the filming of the parkerizing. As you can see, it did turn out good. This is a test fit up, and now it's time to glue up the blade and call it done. Because everything on the blade is black, I'm going to add just a touch of black dye to the epoxy before I glue it up so that if there is anything that does show, it's black just like the rest of the knife. With everything glued up, the last step, let's go put an edge on it. I don't know what angle this is. I tend to freehand my sharpening. They seem to shave good. This one is a dagger, so it gets all four sides. It actually creates a nice looking blade with the glint of steel against the black. And we have our finished blade. I'm going to do a separate video of the sheaths as well. There's two sheaths that come with this, a Kydex sheath and a leather sheath. But if you like this, please like and subscribe and stay tuned for the rest of this build.